right, in this example, we're looking at finding the kernel and the range for the function given below. And the easiest way to do this for sure is to set up our matrix and make an augmented matrix, find the reduced row echelon, and that will help us to find both the kernel and the range. So I'm going to make my matrix. And then I'm going to, sorry, I said I was going to make the augmented matrix because we're looking at setting it equal to 0 to find the kernel. But also remember the reduced row echelon is going to give us our range. So notice we've got two rows that are exactly the same. So I'm going to end up with 1, 0, negative 1. If I do some subtraction here, I'm going to end up with 0, 2, 0, and then 0, 0, 0 down in the bottom. Of course, I can divide this row by 2 to get a 1 here, and then I really have my reduced row echelon. I see 2 leading 1s, so that tells me that my column space has 2 vectors and that my rank is 2. So we can see that the rank of L is 2. That implies that the nullity of L is going to be 1. So we've answered this question. We haven't actually found the kernel and the range yet, though. I've got my two columns with leading 1s. That's going to tell me what my range is. So my range of L is going to be spanned by the vectors 1, 1, 1 and 0, 2, 0. My kernel is going to be the null space. And so I see that I've got one free variable here, which is my third variable. So I could look at this as some value of t. So I would have 1, 0, 1, because in this row, I could say that x is equal to z, for example. So I've got 1, 0, 1. I see that this value, in thinking about my augmented matrix, which I lost, oops, I can see that my second variable is equal to 0. So here's my kernel. It's got 1 vector, as it should, and my range has 2 vectors.